Well, Joey, in the last video we looked at creating this toy building block. In this video we're going to build on top of that. We're going to look a little bit more into parametric design and how to pattern features in Solid Edge. Before we do that, let's save this part as a new name. So I'm going to go to Save As, select the location, give it a name, document number, and the title. So in this video we're going to create a 2x2 brick. And I suppose before we start, maybe let's change the colour of this. So I'm going to open up the style palette. On the style palette I'm going to hit this thumbtack here. We're going to replace styles and select body. And I'm not too worried about what colours, but let's maybe look for plastics. I'm feeling like this. So before we have dragged the colour onto the part, we can do that here again. That's fine. We can also double click on this and just click once on the part. So there's our new part with our new colour. I'm just going to hit save. And the last time we had a quick look at the variable table. So let's open this up again. I'm going to hide that style palette because we're finished with it now. And here you can see all the different variables in the variable table. As I hover over them, the dimension appears on the screen. But, you know, it's a little bit of scrolling and it's a little bit messy. If you remember when I was creating the part that we were given options to give different features names, and I just selected the default values. That's kind of common, but maybe I was being a little bit lazy. Sometimes it is worth investing the time and actually giving meaningful names. We can make things work here. So we can go to the actual dimensions that are meaningful to us. So for example, here is the length, the front length of the part. So I'm looking at the front plane here. That's 7.8 millimeters. So that's that dimension here. So I can just double click on the name and just edit it from this meaningless dimension. So there's one variable that we might want to change. Looking through as well, we have here. So there's the depth of the block. So let's call that. Using backspace. Okay. And then we have, here's the height of the block, 9.6. Now there are some things like the diameter of this peg and the height of it. That's a standard thing in these building blocks. So it's not really something I need to give a variable name because it's not something I ever intend to change. It's a standard. So I think we're in pretty good shape there, just defining those three dimensions. I think we can probably see how we go from there. Right, so we want to create a 2x2 brick. And for a 2x2 brick, I'm actually not even I'm just going to use the variable table. It's very easy to navigate. So I'm just going to click on the value here. And you see the little padlock here? That means it's a locked dimension. It's defined, but we can edit it here. So instead of 17.8, I'm going to type in 15.8 and hit enter. And boom, there we go. And now the length, also 15.8. Enter, boom. So that's pretty cool. The only thing we don't really have is these pegs, these little pegs on the brick. And if you remember, I'm just going to drag this. I can work away, leave this variable table open. I'm just going to move that to a different screen. And if you remember when we created the original part, we defined it symmetrically about the origin of the part. And it has maintained the same origin, so the peg is kind of symmetrical about the origin. But that's kind of not what we want now for our 2x2 part. We want 4 of these pegs spaced equally around each corner. Let's have a look back at our pathfinder. And if I hover over protrusion 1, that looks like it's this rectangular shape. If I hover over protrusion 2, that looks like it's our peg highlighted. So that's actually what we want. And if expand protrusion 2. We have profile 3, which is used to define protrusion 2. So I'm just gonna, usually what I do is I right click and select edit, but let's just have a look here and just click on the feature directly. I right click on that. I'm going to choose edit profile. Now we've zoomed in a crazy amount. So we just have the diameter here of our part, and we have the sketch and the sketch plane. So our part is fully defined. It's a little bit hard to see actually with that red color because the relationships are shown red. So maybe we'll just even temporarily change the color of the part just to make life a little bit easier on ourselves. I'm going to open up our style palette. Right, because I'm in the sketch command, that's kind of not helping us out. So I'm just going to exit that sketch, click finish. Okay, so here's acrylic transparent green. I just double click on that. And now we have our paint bucket. I just click on the part and now we have our part painted green. I'm going to hide our style palette and zoom in on the part. So now we want to edit the position of their peg. So I'm just, we're still in the paint command, but I'm gone out of that now. So if I hover over the feature that I want to edit, it gets highlighted, and just left click on it once and our context toolbar opens up and we have different options here, and I'm just going to select the edit profile. That's the sketch profile that was used to define its position. So I select that and the sketch opens up for that part, and now we can see we have not a lot really defining. You just have a circle, diameter 4.8, and we see this little square here. This is a coincident relationship between the center of the circle and the origin. If I hover over this relationship, it turns orange, and I can just left click on it once. If I press delete, that relationship is deleted. You'll notice, because we have our sketch relationship colors enabled, that the circle has now turned blue. It's no longer fully constrained. So we no longer have a fully defined sketch. I also could have selected the center of the circle and pressed the Alt key and dragged it away to get rid of that relationship. Either way is fine. So now we want to relate that in a corner of the part. So I'm going to select the smart dimension, select an edge of the part, and select the circle. It automatically picks up on the center of the circle. And if I just click to position that dimension, instead of 7.9 millimeters, we're going to give that dimension 3.9 millimeters. And from the other side, we're going to do the same thing and enter 3.9 millimeters and hit enter. So now again, we have a fully defined sketch. We have relationship colors turned on and our sketch has turned black, which means it's fully constrained. So I'm going to hit the close sketch button here to get out of the sketch and click finish, and our extrude feature is reconstructed according to our sketch dimensions. That's actually pretty good, and you can see our whole feature has followed along with it. And you might be wondering how that happened. The way we created our whole feature, that's cutout 4. And if we look at the profile here, if I choose edit definition, let's take a look at the profile here. You can see we have a concentric relationship, which this small circle that defines the cutout is defined by, and this big circle here, which is a construction circle. And you can see this funny symbol here. This is a link. That link means it's linked to something, and what it's actually linked to is the top face of the part. So we created that link by using the project to sketch in the sketch environment. we used project to sketch, and we projected the top face of that peg onto our sketch plane, made our cutout hole concentric with that, so that means it always follows it around whenever we move our top peg. And then we just created this 1.6 millimeter tangent dimension to make this hole have a smaller radius, a 1.6 millimeter smaller radius than the top peg. So that's how we defined our part, and that means that we used kind of good design practice, and that meant everything stayed together. We didn't need to do any work to redefine the hole here. It automatically updated as we moved the peg. We could create 3 more holes, but we could also make life a little bit easier on ourselves, and we could pattern that. We could create a pattern feature. So I'm going to go up to the pattern command, which is in the home tab. Select pattern, and that dialog box opens up. We have different pattern types. There's rectangular, circular, along curve, pattern by table. Rectangular is perfect for this application. And we have selection type, feature, edge, chain, body. Feature is fine. And if we just look at the prompt bar, it's saying click on a feature. So now as I hover over the part, as I hover over different features, they get highlighted. So as I hover over the top peg, it gets highlighted, and I can click on that. And if we go over, it's saying click on a feature. So selected here is protrusion 2, that's the name of that feature. We could carry on with that, but let's kind of be smart here. Let's also pick up this little cutout underneath it. So now we have selected, and in brackets two different features have been selected. And in the prompt bar, it's saying click on a feature. It's waiting for us to add more features to this pattern. That's enough. So I can click on this little tick box to accept our features. And now define pattern geometry. As I move my cursor around, Solid Edge has 2 things going on. It has a plane, and it also has a kind of square. So the outer box here is a plane to define where we want our pattern to exist, and the square is to define the actual layout of the pattern. And if I go up to the prompt bar, click on a face or plane for the pattern. So that's the first thing we want to do. We want to define our face for our pattern. And things are a little bit messy down there, so let's maybe click on the top plane for the pattern. And you can see the F3 with the lock glyph. I'm going to press the F3 button to lock in that top plane where the orange lines are going around, and then there's one green line. So I press F3. Okay, so we're locked in. The little F3 part has disappeared. Our lock has disappeared. And if I go over to the corner of the screen, you can see this F3 lock. So we're locked in on that plane. But it still wants us to click on a plane. So I'm just going to click on that face. And now we get it. It's asking for an X count, and it has 4 pre-selected, and you can kind of see a preview of how our part would look if we accept 4. So because 4 is highlighted, I can just type in, I'm going to press 2, and I'm going to hit tab, and our Y count now is highlighted, and I can press 2 here and hit tab. And now we have a funny looking preview, and it's asking for the distance along the X. It's highlighted 7.61. Actually, we want 8 millimeters between the centers. And for our Y, we also want 8 millimeters between the centers. And I hit tab. And now everything looks kind of good. I can hit enter, and 4 pegs have been created. And we see this rectangular here defining the pattern. We have a name. We can give the pattern a name. And if I click finish here, we've come out of that command. we have our 4 pegs on the top, but also we have our 4 holes, one underneath each of the pegs. If for whatever reason I wanted to change the definition of our original part, if I went to Dynamic Edit here, and I'm just going to temporarily change the diameter of that from 4.8 to 3 millimeters and hit enter, all of the parts in that pattern update because they're all based on the definition of this feature. So I'm going to change that back again, 4.8, and hit enter, and they all update to reflect that. Right, so that's our pattern feature. We're getting close now, but we're not quite where we want to be. For starters, the thickness of these walls aren't right. This is based on the thickness of the smaller brick. We have a normal distance of 1.6 millimeters for each wall. We actually want a 1.2 millimeter wall thickness, and we want to add little bars to make it thicker where the pegs meet the walls. So instead of searching for the feature in the Pathfinder, I'm just going to click on, and I'm going to click inside this time. And now you can see the kind of void highlighted. So I click there and click Dynamic Edit. And now we have our sketch that defines the cutout. And it's basically a 1.6 millimeter dimension here. And you can see another 1.6 millimeter dimension offsetting it from the top face. So let me just click on that 1.6 millimeter dimension, change it to 1.2, hit enter. That changes all 4 faces around there. Our top face is no longer 1.6 millimeter from the top face, it is actually 1 millimeter. It's not the easiest to see, so let's have a look at the section view of it. So I'm going to select the front plane, go to the PMI tab and select section by plane and just press this tick box and click finish. So now we have our section view of our part, and now I'm going to click inside the cube. You can see it highlighted orange, and click Dynamic Edit. That's looking a little bit better. Let's just look at it from the front. And we can see there from the bottom of the cutout to the top face of the part is 1.6 from our original part, but we want this to be 1 millimeter thick. So I'm going to click on 1.6, press 1 and enter. And now our depth has been corrected. So let me just check for starters. So I'm going to go to Inspect, Smart Measure, and the pegs are correct, but the holes under the pegs, I'm not sure what size they are, so I'm just going to measure that. That's 1.6 millimeters, and we actually want that to be 2.6 millimeters. So if I go back up to Home and select, and if I click on that one there, you see the other 3 holes selected along with the pegs. So if you actually look over at the Pathfinder here, that's a pattern. So that's one of the pattern features. You can't actually change a single pattern feature. They're all based on the source pattern feature. So this looks like the source pattern feature is the only one that isn't selected now. So I'm going to turn off the section view, go back over here and take a look at the source pattern feature. So I click on that. I'm going to go to Edit Profile. And now we have the sketch available for us to edit. If I click on the dimension, I can edit the value. But if I right click on the dimension, I have different options in this menu, including delete. So I'm going to select the delete option. That dimension is now gone. We can go back up here, use the smart dimension, go down, and instead of 1.6 millimeters, I'm going to choose 2.6 and hit enter. So that's our hole made larger. So we can go up here and click the close sketch button and finish. We have the name and finish for the cut. And that hole has been updated, and the other 3 holes that make up the pattern based on it have all been made larger too. So one other thing we need to check, the depth of those holes should be 1.7 millimeters from this face. So let me just go up here, go to inspect, and I'm going to select measure normal distance. So from this face to the top of the hole cutout should be 1.7 millimeters. It's currently 1.1 millimeters. So we should change that as well. I click on the feature and click edit definition. We have our sketch and we have our diameter, which is correct. And if we look at the profile here, you see that we defined the depth of the cut as 1.6 millimeters from the top of the peg. So the top of the peg down, it was a from to offset, and it was down 1.6 millimeters. That was how deep we cut out. So it was just slightly above the top face of this part. And let me just do inspect, measure normal distance, just to confirm that. So that should be from here, from there. Oh, now because I'm in a sketch, it's going to the sketch plane. It's snapping to the sketch plane. So let me do the top face first. And now I'll just try and grab a point as the point we're measuring to. And there's 1.6 millimeters. So yeah, so it's 1.6 millimeters. It's a from to off extent and 1.6 millimeters down from the top of the peg. We don't want to use that anymore to define it. So based on our definition, we want to do a 1.7 millimeter extent from this face in here up. So I'm going to go to the feature that we've already defined and click extent. And there's our from to extent. So I'm just going to change that now. And I'm going to change that to a cut finite extent. We have a cut, we're using a cut operation, not automatic. And there we go. So if we go down, we're actually cutting away from the material. It's not actually cutting anything. But if I move the cursor up above, it's cutting up, and I can just type in the distance here. So I type in 1.7 and hit enter. And now I'm just going to accept that name for the feature and click finish. And just to confirm, we're in the inspect, and I'm going to click measure normal distance. Select any one of these because they're all changed now. That's from the cut to the face, and the distance is 0.85. That's wrong. Okay, so what went wrong there? Okay, let's take a look at that. 0.85 is a suspicious number. 0.85 is half of 1.7. So I suspect what I did wrong there was it was a symmetric extent. So let me go back to the extent here. And yeah, you can see here, symmetric extent. So it cut half of 1.7 up and half of 1.7 down. So the half of 1.7 down was just cutting into free air and wasn't really doing anything for us. So these things happen. So I'm going to use a one-sided extent. And we're not cutting down, we're cutting up. And I type in 1.7 and hit enter. And now I just click. We can just accept the name and click finish. And now let's just check that again, because apparently I'm human and I make mistakes. So let's just 3D measure. Select this face and select the end of the cutout. And there's 1.7 millimeters. So we're good. In our next video, we'll continue modelling this part. We'll add the hollow cylinder to the underside, extrude ribs around the inside walls, and learn about the mirror feature command. Thank you.